Section 8.3 is angular and linear velocity. What's the difference between angular velocity and linear velocity? Angular velocity is measuring how many times something goes around in a circle. Now that can be measured by revolutions, rotations, degrees, or radians per unit of time. Anytime you have a velocity, you're comparing two different things, with the second thing being time. So just as an easy example, angular velocity is the number of times a circle revolves per unit of time. An example, 7 revolutions per second. Doesn't have to be revolutions, it could be 7 radians per second or 7 degrees per second. Doesn't have to be seconds, it could be minutes, hours, days, leap years. Linear velocity is like when you're in a car. If you have a wheel going around and you're measuring how many times it goes around in a unit of time, that's angular velocity. If the wheel's on the ground and you're pushing a car forward, vroom, and this car goes forward and it's going 10 miles an hour, its linear velocity is 10 miles per hour. You could say each wheel, its angular velocity is 7 revolutions per second. Linear velocity might be 10 miles per hour. So, example for linear velocity, 55 miles per hour. Doesn't have to be miles. It has to be some type of linear measurement, inches, feet, kilometers. Distance formula. S equals V times T. S is the distance traveled, V is the velocity of the object, and T is the time in which it's been moving. Here's some random facts that are not that random. 1 revolution is equivalent to 360 degrees. I believe you already know that. That's also equal to 2 pi radians. I believe you already knew that. It's this next one that people forget about, and when forgetting about it, gets you in lots of trouble. 1 revolution is also equal to the circumference of the circle. Circumference for a circle is just a fancy word for perimeter of the circle. To find the circumference, you multiply 2 times the radius times pi. Or, for circumference, you could multiply the diameter times pi, because the radius is half the diameter. In either case, you're going to have some kind of linear unit with this. Linear unit meaning something like inches, feet, miles, kilometers. Please note in your notes that this is referring to circumference. The reason I'm asking you to note that, that's the part that I'm afraid you're going to forget. Circumference and 1 revolution are equivalent. Other facts that you should know, being an American. 1 foot is equal to 12 inches. 1 yard is equal to 3 feet. 1 mile is equal to 5,280 feet. Let's see. 1 hour is 60 minutes. 1 minute is 60 seconds. 1 kilometer or kilometer is 1,000 meters. 1 meter is 100 centimeters. These are facts that you should know. The one that I'm most concerned about you remembering is that 1 revolution is equal to the circumference. Let us do an example. Example A, answer the following questions. Round to the nearest tenth. Let me add something to the directions. Round to the nearest tenth for linear velocity. Give exact answers for angular velocity. In the future, I hope that my directions are written in a way in which I intended them to be written. These directions are poorly written. Let's read this problem. A pulley of radius 12 centimeters, radius of 12 centimeters sounds important, turns at 7 revolutions per second. 7 revolutions per second is more than just important. What is the linear velocity of the belt driving the pulley in centimeters per second? The question is, in the box, to change this to centimeters per second. First glance, this seems hard, if not impossible. This is actually really easy. Take the rate in which you're given. A rate is a comparison of two numbers with different units, and that is 7 revolutions per second. Write it as a fraction. Then that needs converted to centimeters per second. Now fortunately, the bottom is already in seconds. We just have to convert the revolutions to centimeters. So we go back up to our not-so-random facts. We are currently in revolutions, so we could change it to degrees if we wanted. We could change it to radians if we wanted. We could change it to a linear unit if we wanted. Which do we want to do? Well, we're supposed to change it to centimeters, which is a linear unit. So we're going to multiply this by 1 in the form of something divided by revolution. Why is that on the bottom? So we can cancel revolutions and revolutions. To get centimeters, we're going to use circumference. We're told the radius is 12. 2 times the radius, 12 centimeters, times pi. This is equivalent to the circumference. In your notes, note that that's a circumference, because you're going to look at your notes later and not know what that is. When you put a number into this, you must label that number. In this case, it's in centimeters. Since the revolutions canceled, our units that we're in now is centimeters per second, which is what the directions told us to do. How convenient. 7 times 2 times 12 is 168 times pi. Our units are centimeters per second. This is a linear velocity, so put that in your calculator at around the 1 decimal place, and I think you're going to get 527.8 centimeters per second. That's it. In my opinion, this is the hardest type of problem, one in which you have to recognize that you're using circumference, and that's equal to a revolution. Let's do another. Convert the angular velocity of 1800 revolutions per minute, RPM is revolutions per minute, to radians per minute. The directions are to change it to radians per minute. Take the rate in which you're given. We're given the rate of 1800 revolutions per 1 minute. We have to multiply this by 1, because if you multiply by 1, it doesn't change its value. But we want to change the units. 1 revolution is equivalent to 2 pi radians. Since we're multiplying and dividing by the same thing, revolutions, they cancel. Now we are in radians per minute. 1800 times 2 is 3600 times pi radians per minute. This is an angular velocity because it's in radians. So for angular velocity, we're going to leave our answer as exact, not rounded. Number 3. Change 40 miles per hour to inches per second. So here's the units we're currently in. Here's what we're trying to get to. 40 ma divided by 1 times. We need to get miles into inches, hours into seconds. Don't rush into it. Just do one part at a time. These multiple fractions we're going to use can be done in any order. I'm going to try to get miles into inches. I have no idea how many inches are in a mile, but I do know that 1 mile is 5,280 feet. As every red, white, and blue-blooded Americans should know. Miles cancel. Now we're in feet per hour. To change feet to inches, I know that 1 foot is equivalent to 12 inches. Notice each time I write a fraction, I'm writing the units on the opposite side of the fraction so they cancel. Now I'm in inches per hour. Pardon me, yes I am, inches per hour. I need to get into inches per second. So I'm going to multiply by 1 hour is equivalent to 60 minutes. Hours cancel. Then I'm going to multiply by 1 minute is equivalent to 60 seconds. Minutes cancel. Now I'm in inches per second. If you multiply those little fellas out, multiplying the top, you're going to get, just on some quick mental math, 2,534,400 inches. 3,600 seconds. This is a linear velocity because we're in a linear unit, inches. If you were to divide that, it would come out to be exactly 704 inches per second. Number 4. A trucker drives 55 miles per hour. That's the rate we're going to start with. His truck tires have a diameter of 26 inches. What is the angular velocity of the wheels in revolutions per second? So we need to convert miles into revolutions, hours into seconds. Now I know that 1 revolution is equivalent to the circumference. Unfortunately, the units of the circumference is inches, and I have 55 miles. Once again, you can do these fractions in any order. I am going to try to change these miles to inches first. 1 mile is 5,280 feet. And if I want to get rid of feet and get it to inches, 1 foot is the same as 12 inches. Now I'm in inches per hour. I want inches to be revolutions. So to get rid of inches, I need to use circumference. I'm given the diameter, so 26 inches times pi. Once again, make a note that that's circumference. If you don't, you're going to look at this later and you're going to think, what in the heck is 26 inches pi doing there? That's equivalent to 1 revolution. Hardest part's over because we've converted miles into revolutions. Now we need to convert the hours into seconds. And I'm running out of space here, so I'm going to do one of these little fellas. I want the hours to cancel. 1 hour is the same as 60 minutes. I want the minutes to cancel. 1 minute is the same as 60 seconds. Hours cancels here. Minutes cancel here. The only units that are left on the top is revolutions. On the bottom is seconds. If you multiply this out, this ends up being 3,484,800 revolutions over 93,600 pi seconds. So I'm at the risk of contradicting myself. I said in the directions, if it's an angular velocity, just leave it with the pi in it, exact answer. Well, this exact answer here it's a little rough. So if I put this in my calculator, it ends up being about 11.9 revolutions per second. When you put it in your calculator, it's important that you put the denominator in parentheses because there's 2 factors down there. Please put this in your calculator, this part here, right now, and make sure you get 11.9. If you don't, can't figure it out, make a note of it. and then you can ask me about it at school. One more problem left, 3 parts. The CD is 4.7 inches in diameter. That sounds important. Spins at a rate of 1600 RPM. That sounds essential. What is the angular velocity of the CD in radians per minute? Well, we're given this ratio. We're supposed to change it to radians per minute. The bottom's already minutes. To get into radians, 1 revolution is equivalent to 2 pi radians. That's one of the facts that we wrote on the front. Revolutions cancel. We are in radians per minute. This is going to be 3,200 pi radians every minute. Part B. How fast in inches per minute would the CD move if the laser is at the end of the CD? If the laser is at the end of the CD, that means we're using the entire diameter of the CD. So we take the original rate we were given, 1600 revolution over 1 minute. To get it into inches, we're going to multiply by 1 in the form of the circumference over 1 revolution. The circumference is going to be 4.7 inches times pi. Revolutions cancel. This ends up being 7,520 pi inches per minute. That's an exact answer. Once again, on the test, I'm going to try to be much more clear about what to round to, if you're supposed to round or not. Right now, my directions are unclear. If you multiply that out, because it's a linear velocity, we get 23,624.8 inches per minute. Last one. Convert the previous linear velocity to feet per second. When we do that, it's essential that we use the one that's not rounded. So we get 7520 pi inches for every 1 minute. To convert it to feet per second, well, this shouldn't be too bad. 1 foot is 12 inches. Inches cancel. Now we're in feet per minute. We need to be feet per second. 1 minute is 60 seconds. Now we're in feet per second. That's going to be 7,520 pi feet for every 720 seconds. If you divide that, that's about 32.8 feet per second. That concludes the notes. I hope that you feel better.